Okay, this is a video to assist you with the investigation, characteristics of properties of functions. So to do that, we'll take a look at the first graph and equation that we have here to represent a polynomial function. So the first one we have here is a familiar one. It's a graph of a parabola, and if we look at the equation, we have a quadratic relationship, x squared plus 4x minus 5. And from this graph and this equation, we're able to pick out properties. We know this is a polynomial function because all of the exponents are whole numbers, and we have x as our variable on the right side. We know this is a degree 2 polynomial because the exponent on the largest term is 2. We know that this is an even degree polynomial because 2 is an even number. And if it was a degree 3, then we'd say it's an odd degree. Okay? The leading coefficient here is plus 1. The leading coefficient comes from the number in front of the term with the degree in it. So in this case, this is the term that says it's degree 2, and that would make that the leading coefficient. And that's the degree. Since you can't see a number there, we assume it's 1. There's no negative sign, so that makes it positive 1. End behaviors? Well, we're just looking at the ends of the graph. So our ends are up here and up here. So our first one is as x approaches negative infinity, y approaches positive infinity. That means as we go to the far left of the graph, where's the graph going? Well, it's going up to infinity. And as x approaches positive infinity, we're going to the far right of the graph, which means we're going up to the right, and again, we're approaching positive infinity. Number of turning points is how many times the graph changes from decreasing to increasing or increasing to decreasing. How many times we turn from going down to going up or from going up to going down. So if we trace across this graph, we're decreasing, 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 and we reach a turning point right there. That's a turning point. And then we turn and start increasing or going up. So that means we have one turning point. One turning point, and it is right there. And it's called the vertex on a parabola, and it's actually also called an absolute minimum in this case. It's not called a local max or a local min because it is the absolute minimum. There is no absolute maximum on this graph. There is no local maximum. There is no local minimum. Just an absolute minimum. Okay, we'll do one more. Our next equation is f of x equals x cubed minus 2x. And what you'll notice about this graph is it doesn't quite look like the parent function for the cubic. As you saw yesterday, the power function x cubed just had an S shape. It didn't actually go up, then down, then up. It's that linear term that makes it more apparent that there are multiple turning points here. And that's not a transformation that you're used to seeing. And it's not really described as a transformation either. It's just changing a power function, there, x cubed is a power function, into a polynomial function, which has multiple terms. Power functions are also called polynomial functions. However, once we have a second term, it's no longer called a power function. It is only called a polynomial function. So we have a polynomial function. Its degree is right here, 3. That's the highest exponent on an x. The other exponent would be 1. We don't add the degrees. We just take the total from the biggest term. The exponent, not the total. The exponent from the biggest term. Is it even or odd? Well, it's odd because 3 is an odd number. The leading coefficient, again, is 1, and it's plus 1. End behaviors, as x goes towards negative infinity, this graph is going down. So y will approach negative infinity. And as we approach, x approaches positive infinity or goes to the right, y is also increasing and going up. So y approaches infinity as well. Number of turning points, we're increasing to here, and then we start decreasing, so that's 1. And then we start increasing again after this point, so we have 2 turning points. 1 and 2. Okay. Hopefully that's enough to help you with the investigation. So keep trying, and if you have further questions, check the solutions to see if that helps you, and if it doesn't, check with me in class. Thanks for watching.